All right, it is time for our first practical test of the refractometer. And to do that, I need a very pure sample of toluene. But I really only have this hardware store, industrial grade toluene, which is likely contaminated and probably has some water, which is going to throw off our reading. So to purify the sample, I've added a little bit of the toluene to this flask with sulfuric acid, and that will do two things for me. The sulfuric acid will destroy any thiophene, which is a common contaminant in toluene, and it should sequester that out of the toluene. Additionally, it should help pull any water out of the toluene. So I have this just stirring with a drying tube, and the drying tube will help if there's any gas produced, which I don't expect there to be. The system won't pressurize. And also that'll help prevent any ingress of additional water while this is stirring. Interestingly, when I poured the toluene in, it was crystal clear, the sulfuric acid was clear, but when they came into contact with each other, it became very murky, kind of a milky color, and it's since turned yellow, and it's been stirring for about 20 minutes. So we'll check back in about an hour and see what it looks like. This is the refractometer we're going to test. It's a digital refractometer, Abbey Mark II, and I got this thing for a steal. It was, I think, dropped at one point. I don't know if you can tell, but the arm with the light is a little bit bent, and inside, where this adjustment wheel connects to a gear, was off the rail, and it wasn't actually moving that little pulley along the rail. I was able to get that back on, and it powers on, and I did a test just with distilled water, and it landed right where it was supposed to. I've got the hoses to be able to circulate some water. It's got a digital thermometer built inside, so we should be able to account for temperature. And really what I'm trying to do now is, with the water test out of the way, I want to test something like toluene so we can move up the scale and make sure it's still reading true. I am not an expert on these machines by any stretch of the imagination, so I did a lot of reading, and kind of the most important thing, aside from it turning on and reading, is that these prisms are in good condition. And from the pictures I saw and the manual I was able to download, they look good enough. Some of this cloudiness here didn't seem to be a problem, at least for the water test. I can't tell if this is a chip right here or not, but we'll really only be able to tell if it's going to work by testing it. So on with the test. I wanted to give a good look at this machine. It'll probably be dark by the time I actually get to the testing. I started this whole process pretty late. And I forgot to mention just what an absolute brick this thing is. It's pretty cool. You just don't really see things made like this anymore. Okay, this is about an hour later, and it looks a little darker to the eye anyway, and it looks like it's starting to clear up a little bit. I'm trying to do a better job about not shaking the camera all over the place. So that's about an hour. We'll let it go for at least another hour and come check it again. So the more I look at that spot, I do think it's a chip because it lines up with all the scrape marks on this light cover that was pretty banged up. So I'm wondering if when it fell, it smashed up against that. But it didn't affect the water test, so I'm hopeful. And I think really the whole point of this experiment is that this piece of equipment is significantly more precise, or at least has the potential to be more precise than anything I can do. So if it works, that'll be fantastic, and it'll be a lot of fun to see if I can't get something that's, say like hardware store quality, to read where it's supposed to read, and for this thing to work across the full spectrum it can read. And yeah, so updates to come. All right, here we are about an hour later. It's officially dark outside, but can't tell if that's more clear, maybe a little lighter. But in any case, we're going to move forward. So the next step is I'm going to transfer all that over to this separatory funnel. And since this experiment, I guess we'll call it this test, is really based on getting the purest sample. We know we started with toluene. Now the goal is just get as pure as we can possibly get, because the sample really isn't what's being tested here. We have a known value for what the refractive index of toluene should be. The real test is for the equipment. So with that being said, I should dry this glass and get as much water out of the system as possible. However, this will still carry over with sulfuric acid. So I'm less concerned about this glass. It is the glass that I transfer this to for the distillation that needs to be exceptionally dry. So we'll deal with that next. I'm going to go ahead and get this transferred over. All right, you can see that the two layers have separated and all that gunk and yellowish crud is now down with the sulfuric acid layer. So what I'm going to do is transfer this over into the separatory funnel and then give it a good shake just to capture any remaining moisture that might be in that glass. Let it stand and separate these two out and get ready for distillation. So we're all set up for fractional distillation here, and I noticed it looks like we're starting to get some kind of clear crystals on the walls of the glass, and this should not be the thiophene. That should stay a liquid at room temperature, so not really sure what that is, but ideally the fractional distillation will get rid of it. So we're all set up here with a relatively short fractionating column, and I opted for a air condenser. My thought is essentially that I don't want to super cool the toluene vapor as it comes across, because I want the best possible separation from any water. So that may be flawed thinking there, but that's what I was thinking. Oh yeah, we are on the move. It looks like we're gonna overdrive this column a little bit, which again is okay. We're gonna discard everything that comes across in this first little fraction. With the thermometer up so high in the column, the heating mantle just goes crazy until those vapors finally hit the probe at the top, and then it's usually like whoa and dials it way back down. So that's normal. It happens all the time. It'll jump past my target, and that's okay. We'll dial it back in. But you can see there's the phases. Beautiful. This is a little bit discouraging, but you should be able to see that cloudiness. There's definitely contaminants coming over, which doesn't really surprise me since we just way overdrove the fractionating column to get this, but I would be happier if this wasn't even present in the boiling flask to begin with. So we'll see what we get, and we might have to do some more steps after this. Toluene is not really what's being tested. The toluene has to be good, has to be clean and very, very pure. So all of that is just introducing error in my mind, but we'll see what we get. Now, just looking at our aqueous layer that we drained away earlier, there's this iceberg of a waxy crystal floating in there, and I was thinking, I wonder if that's cool. I wonder if this is either some kind of paraffin like wax or something like benzoic acid. But I will say, when this was underneath that toluene layer, it was not crystallizing out. This is cool. So now that all that initial gunk made its way over, we have this beautifully clear vapor right at the neck of the condenser. Yeah, I mean, just look at this by comparison. Beautifully clear. You can just barely see it. Looks like I'm just showing an empty tube. But it's there. We are in our target zone. We are overdriving the column just a tiny, tiny bit. You can see it's a little bit high on the joint there. We really just want it right here, right at the joint. But toluene boils around 110 to 111, so we get a little bit of room in there. We also just want to be careful not to push it too hard because I'm counting on airflow to cool this down to condense back into a liquid. So if this line, which is right about here, starts to make its way down to the clamp, we're going to have to back off. Otherwise, we're going to be bringing over things we don't want. But right now, I'm capturing it right in a brand new container that has had nothing else in it. It's just been sitting there, empty, dry, clean for months. So, and there's probably some water in there now that I think about it. It's a very interesting problem because the more you think about it, there's little bits of error being introduced into it, which is kind of the fun. It's also very frustrating. One thing that I forgot to say that you can see, none of the joints have any grease. They're all PTFE, pipe thread, a plumber's tape, and that's just to keep any of that grease from getting dissolved and making its way down into our collection bottle here. We are getting a little warm in the column. It's just about to the clamp, and when I start to see condensation here at this last little shoulder joint, I get a little concerned. But we don't have that much further to go, and we're not going to go all the way to dryness. We're okay with some loss. We just want the best possible fraction we can get, kind of in the center-ish. And we should be at about 75. Not that these lines are accurate. But that's more than enough to do a calibration test. And if we have to do another distillation, it might be a little bit tight, but we will see what we've got. I think I had higher hopes for that initial cleaning step with the sulfuric acid. You can see down in the bottom of our boiling flask, we've got some gunk, but that's okay if it stays there. But there's going to be some minuscule amount that is still going to contaminate our final calibration test. So we might have to run another one, but it's not going to hurt to test what we've got anyway, and just see where we shake out. And there it is. I'm about to turn the heating mantle off. We jumped up to 111 and dropped back down. And you can see that the vapor front is starting to fall in the column. So it's going to climb back up when some of this starts to boil over. So this is our chance to stop that, shut it down, and save what we got. We're right at about, I don't know, 80-ish. Again, those lines don't really mean anything, but volume-wise, we have more than enough to do some tests. Here's the toluene we collected. We'll use for a test. I won't say the test in case, it's not reading where it should. That could be a problem with the toluene, which is kind of the whole point. The goal here is to have a known, very pure sample to test the refractometer, not to test the toluene. So we already know some of the places some error could have been introduced, but we won't really be able to tell until we test it. Okay, so I'm at a good stopping point for tonight. You can see what's left in our boiling flask. Focusing there. Actually less than I thought there would be. Some of it continued to come over, so I collected it here. We're not going to use any of that. And I'm just neutralizing the sulfuric acid that was used in our first cleaning step. So I can dispose of it, and we'll pick back up tomorrow and see where we're at. All right, we are back and ready to do a test. Got the water pump set up, circulating just some tap water through the prism here. And my thought is just, I can't control the temperature of the water very effectively, but at least it will be consistent. And if there's, an air gap from where the digital thermometer is to the sample, at least now there'll be a liquid that can conduct across that. So there'll be a consistent temperature for the reading. So we've got our sample of toluene and some distilled water, and we'll run both of those tests to see if this thing is working or not. Some considerations for our test are that, when you are testing the purity of things and, you have the option for recrystallization, or, you can do a titration or measure mass versus volume. Some of those really do test my skill level, particularly when it comes to things that are not binary. It's not just water and toluene. So for this test, the theoretical refractive index for water is 1.330 at 20 degrees. And for toluene, that should be 1.4967. However, it's raining, so we can account for some water inclusion in that, which should push it up the index a little bit. And as we talked about yesterday, wasn't able to really eliminate water throughout that process. There's surely better methods than what I did. However, this should be pure enough for our test, so we'll see what we get. When you're measuring the purity of things and you have the option to do a recrystallization or, a titration, those are excellent processes to follow. They do test my skill level, to be honest. And when it comes to something like this, there's an additional layer of challenge for that when it's not just a binary consideration of, water and toluene. We have to consider that there might be other contaminants that are hard to parse out using those processes. So recrystallization is great, but we're dealing with liquids today, so we have to follow something else. And it's raining today, so the humidity is going to be pretty high. We can expect that some water, either through the process it followed yesterday or today, might push the reading up the scale a little bit, and that's fine as long as I land inside the band that is documented to be the known range for the refractive index for toluene. All right, we'll get a reading for our distilled water. Record all 4 digits. And then check our temperature, which apparently is right at 20 degrees C, which is perfect. So it looks like our water sample is right on the money. We'll get the prism cleaned off and move to toluene. All right, 4976. We'll get another temperature reading just to see if that's moved. Still 20 degrees C. All right, this thing looks like it's right on the money. That's pretty exciting for me. We were able to spend basically $0 aside from, things I already had on hand. Take the side cover off, get this thing back on the rails, get it calibrated, and it's reading right where it needs to. So now we can do some more sophisticated tests with it. This has been a lot of fun for me because most of the projects I take on, I really have no method of testing how precise I'm really being, aside from does it look right, does it smell right, does it taste right? There's no way really to know, but with a piece of equipment like this, now I can actually take a refractive index and see if I'm landing where I want to land, test purity, things like that. And the research I did said toluene was an excellent sample to use for this just because it's so well documented across all the different temperatures, that we could get a reading for. So yesterday I was having a really hard time. It was reading at 25, 19.3, and today conditions just seem right that the ambient temperature for the water is right where it needs to be to run a perfect test. 20 degrees C is really the standard from what I read. So that's perfect. All right, thanks for watching.